I want to prepare our next speakers to come up stage, which is going to be about rebuild, plug-and-play renovation for a circular future. And for that, I want to welcome on stage Elisabeth Leitner. She is a project manager at GRÜNSTATTGRAU and RENOWAVE, as well as Susanne Formanek. She is the CEO. Please, stage is yours.
Hello, and thank you also from our side. We are here today together with Susanne Formanek on the back, so if you want to talk to her, you can also do that later. I'm going to present you the GRÜNSTATTGRAU and RENOWAVE challenge. It's called Rebuild, Plug and Play Renovation for a Circular Future. Today we have two presentations here on that topic. And the topic was to further develop the renovation process of existing buildings by creating sustainable plug-and-play solutions using minimal resources, recyclable materials, and also include green solutions. So the challenge was to include the greening solutions into scalable, prefabricated renovation systems. And starting with the first presentation, I would like to welcome Burkhard List onto the stage.
Thank you very much. There we go. So, my name is Burkhard. I'm the founder of b&mi. And I'm mainly working on innovation projects. And today I want to tell you why maybe the solution of GRÜNSTATTGRAU and RENOWAVE is maybe not as technical as we might think. Well, when I was jumping into the topic about greening buildings and industrial renovation, you soon will find out, well, there is a lot there. We know the processes, we know the plants, how they're growing. We even know the impacts that we are having. We're knowing the processes of renovation, how to put it together. But in the end, we are not scaling. And maybe it's not because we don't know how, but maybe it's because how we look at the topic. I'm coming from a totally different domain, actually, yacht building. And in yacht building, assets are never built to be finished. They are constantly improved, developed, updated, so they are actually built or designed for the next period of operation over decades or even generations. And I think exactly that's where we need to look differently into the building world. And to work on my solution, I had to steal one of your slides from the challenge pitch, because it showed for me the big topic we are facing here. When you look at the slide, you will see, well, when we shift all those buildings that we built in the last 80 years to the future, we definitely have a big need for renovation, oh, don't we? I think so, yes. But if we see this topic as a scaling problem or a scaling problem, all we will do, we will shift the thing that we did 80 years ago to the next 80 years. So we are not actually improving or changing anything. But if you see it as a system problem, we have the big chance to actually scale the performance of the buildings. Well, how does construction industry look at it? They see project after project, case by case, and mainly the whole thing is driven by euros per square meter costs. When we then talk about renovation or even the greening of a building, then that's just another line on the list, and costs increase. It gets more expensive, and that just doesn't help us. But instead, buildings are not just products, they are actually a big system. And I want to talk about a little bit how the photovoltaics industry did this in the past, because they were facing the same problem actually. Think about PV maybe 5 or 10 years ago. They were expensive, there were complex systems, actually only for, let's say, organic nerds, a niche thing for organic nerds, but it didn't really scale. But then a system around evolved. Suddenly, you could decide what you do with your energy. Do you want to use it yourself? Do you want to sell it on the market? Or even just share it with your neighbor? And suddenly a system involved, and nobody would dare to think about building a house today without a PV on the roof, or won't you? And I think that's where we need to look at to make renovation and greening buildings really scalable. So what can we learn out of this? Well, today when we look at buildings, we really look at them box by box. They are isolated, they have a big fat boundary around them, and within this box we are trying to improve them or make our decisions. So let's say we talk about the facade and we are thinking about improving the facade of this building. Well, we definitely will find out, okay, it will have an impact on the energy consumption of my house, but then comes the big cost tag. It will have extra cost, and I don't know if only within our box we will find an appropriate solution for that. But then let's introduce industrial renovation to it in form of the facade again, and also greening of the building. And what happens now is very important to recognize, and I think that's exactly where we need to look to solve this challenge. Suddenly, our building is not a project, a box, it's a system, a broader system. Our boundaries expand, it jumps to the next building over there and even onto the street. And when we now look at our case where we say, okay, we improve our facade, what we find out now, okay, for sure, it still has an impact on our energy within the house, but it has a big effect on, for example, the microclimate around the building. So suddenly, the impact of our renovation jumps onto the street, onto the neighbors. Maybe people sitting in the small cafe back there, they enjoy their cafe because it's getting cooler, we get a much nicer climate around. And even the municipality, maybe they need to redo their paving not every 5 years, but only every 10 years. So suddenly, it's not a cost tag that we're putting to it, we are putting a performance tag to it. And suddenly, we can discuss which stakeholders in our system improve or take advantage of our bigger, greater system. And that's, I think, exactly where we need to go. And that's what we want to build. We want to build those systems around the technical element. So, summarized, as long as we are talking within greening buildings and renovation about only the costs, the euros per square meter, I think we are lost. We won't make a move forward. When we start making the shift to the performance over time, to value the performance over time, that's exactly where we will improve and where we have the system that is possible to scale renovation and also greening buildings. So, in the end, when you think about photovoltaics, they became a standard when they managed to have a system around. I think we're definitely not lacking the technical side. We definitely need to work on the system around to make this scaling. Thank you, and thanks a lot to Susanne and Elisabeth, who put this challenge out and who were great hosts to us during this challenge. Thank you.
Fantastic. Thank you very much, Burkhard. And next on stage for the GRÜNSTATTGRAU and RENOWAVE Challenge, I want to welcome Team Elena Hausner from the IMC Krems, Johannes Spitzer from Forschung Burgenland, Michelle Jane Dote, I hope I didn't mispronounce Dote, I'm sorry, and Elin Holmqvist from the University of Applied Sciences in St. Pölten. This is your applause and the stage is yours.
Okay, So hello everybody. We were one of the teams that was also working on this challenge, and we came up with a modular solution to combine insulation and greenery in the process of renovating houses. But how would this look? So in our system, we would start with a wooden frame that is placed to the side of the house. And on top of this wooden frame, we have a modular system, which is like a box system that is, and these boxes can be stacked on top of each other and are then screwed to the wooden frame. After this process is finished, we add the irrigation system, and the system is ready to grow some plants. But let's take a look at the technical side of this. So instead of having one system for the insulation and one system for the greenery, we decided to combine it into a box system, putting the greenery on the front side and the insulation on the inside of the box. And as you can see on the picture, these modules are not too big in size, which means that they are easily handleable by construction workers on site. And this is how one of these modules would look. Elena will then give us a brief intro to the materials. So as you can see, the insulation is put on the inside, and the substrate for the plants is stable too on the outside.
Thank you, Elin. I will take over from here. Now I'll briefly explain to you the production process, the materials used, and also the circularity. Let's start with the production concept. The process can be split into 4 total working steps. First, there is a plastic frame that is going to be produced, and inside there can be the insulation material inserted. Afterwards, a wooden frame is produced and attached onto it, where the greenery is going to be put into at the last step. And then a foil is mounted onto the insulation material. Next up to the materials used. We use acetylated wood for the structure, which is lightweight, durable, and also moisture resistant. Also, the sides are closed with plastic panels to avoid thermal breaches. And inside, a loose organic insulation material adapts to the existing wall, improving energy and performance. Now to the circularity. The system is designed as full recyclable solution. It uses no adhesives, so all materials can be easily separated. And the lightweight structure reduces resource use, and the insulation even stores CO2. In addition, the integrated greenery supports urine cooling through evapotranspiration.
So now to the greening part, we have come up with 3 different variants, and each one is adaptable to the buildings or the customer's needs. The first variant is an open substrate frame, where the substrate is put inside of the frame that allows the plants to grow horizontally outwards. So the result would be a full surface coverage of the greenery. The second variant is a modular hook system, where holes or openings are made in already made pre-manufactured. So on site, the customers can adapt or can use their preferred plant container onto the hookings, which makes it very customizable, as well as you don't need any structural changes. And the third variant is a foldable substrate containers, which is very transport efficient, because you can fold it and then you can pop it open on site in the installation. And the front part is rigid, whereas the side parts are made out of a flexible plastic film, for example, which makes it foldable. And all of these 3 variants are based on meandering drip principle. So even water distribution is possible through a serpentine-like pattern. The supply line is vertical and is mainly connected to the water source The modules can be connected in a series, and the flush valve enables a very easy drainage and maintenance. So yes, this is our solution to the problem, which is still recyclable, resource efficient, and includes the greenery. Thank you so much for your attention. And yeah, I hope you enjoyed our presentation.
Right on time. Please stay on stage, and I also want to invite the challenge partner as well as Burkhard to come back on stage, collect your awards, and have a quick picture. Please grab your awards.